So let us understand what are the deficiency symptoms of various essential elements. By this time you have already understood what are the essential elements, what is the role of each and every essential element, whether it's macro and micro. So based on the role, it becomes easier to understand the deficiency symptoms, but let us understand it further so that we can have a more clear clarity. So the deficiency symptoms of essential elements can be understood when specifically the growth is retarded. Growth is retarded means what? The growth is not happening at the same speed and in the same pace as it is supposed to happen in the normal conditions. And this happens when the supply of the essential element is limited. Limited means it is not required to as much as the required quantity, or it is deficient. The concentration of the essential element below which the plant's growth is retarded is called as the critical concentration. So anything above critical concentration, if that element is supplied, the growth will happen, even if it's not the exact amount. Let us say if you need 10 grams of an element hypothetically, and even if you are getting 4 grams, the growth can still happen. Why? Because even though 10 is the required quantity, the critical concentration is 3. So the amount that the plant is getting is more than the critical concentration, so growth can happen. But if the amount is less than 3, then it will show severe retardation. So that specific amount, which is now critical concentration, is not the exact required amount, but it is that amount till which growth can happen. Okay, so the element is said to be deficient only when it is present below the critical concentration. Even if it is just above the critical concentration also, the element is not supposed to be deficient, because it is still able to carry out normal functions even though it is not there in the required quantity. So here is a graph that can explain the whole issue. So this is a plant yield and this is the concentration. So on the x-axis you have the concentration of the nutrients in the tissue. On the y-axis you have the plant yield. Now this range here shows the highest plant growth, and this is happening when the nutrients are in this range. Okay, so when the range of concentration of nutrients is somewhere in this block, then the growth of the plant, the yield of the plant is in its maximum stage. That means what? That means that the plant nutrient growth is sufficient. Now, if you see the same graph again, let me take another color so that it becomes easier. If you see the same graph again, from this point, this is the initial amount, right? Now, next to this point, this area where I am drawing lines, here the growth is not that great. So if the nutrient concentration is in this area of the graph, then we call it as deficient, because it is not in the sufficient category. How will it reach the sufficient category? It has to cross this border of critical concentration, after which the growth becomes stable due to reaching the required amount. Now, if you see, there is something else that is going on here in this ratio. Once the range of the concentration has come about to the next level, when it is crossing this threshold, of concentration, again the plant growth is coming down. Then here what happens? Here it is excess. So it means even if the mineral elements is excess or if it is deficient, the plant growth will not be proper. It should always be within that range, this range from here to here, where it is sufficient enough to carry out good yield. So this range is called as the critical range. The critical range has 2 pointers. One is the minimum concentration Other one is the maximum concentration. So if any element is less than the critical minimum concentration, we call it to be deficient. And if any element is more than the critical maximum concentration, we call it as toxic or excess in nature. Right. So this is your critical concentration, the concentration of the essential element below which the plant growth is retarded. Now, each element has one or more specific structural and functional roles, and based on the element's structural and functional role, a particular part of the plant or an entire plant can show morphological changes. Okay, like see here, these are the few examples here. So let us see each element into detail. Now, all the elements' morphological details, they are explained together in a deficiency symptom, and majority of the agriculture, horticultural institutes or people where there is work going on plants, you can see these kind of charts that are available, these kind of charts which clearly show the deficiency symptoms. So the deficiency symptom, it will vary from element to element. No element will have the same kind of deficiency symptom, and as soon as the deficiency is overcome, means let us say if nitrogen is deficient, if you're giving ample amounts of nitrogen, then the deficiency symptom will disappear. But even after getting the deficiency, if you are not changing it, if you are not providing it, if you keep on depriving it of the essential element, then the death of the plant will occur. Okay, so various parts of the plant which show the deficiency symptoms. Which parts show the symptoms? How can you say which part will show it? Well, it depends on the mobility of the element. Now, what is this mobility? Mobility means element moves from one place to another. Mostly it moves from old parts of the plant to young parts of the plant. Let us say when a leaf is dying, if it's got some elements, it's already dying. So what it will do, it will send all its mineral elements to its younger counterparts. But do all elements move? No, all elements are not mobile. Based on whether they are few are mobile and few are immobile. So if elements are actively mobilized, then they are exported to young developing tissues. So their deficiency appears in the older tissues because older tissues are not having it. Whatever older tissue will have, it will take it from the root, because whatever it has in reserve, it has given to its young plant. So mobile elements deficiency will be shown in the younger tissues, where, for example, here is nitrogen, potassium and magnesium. These are all mobile elements. So the deficiency you can clearly see in senescent or old leaf. See, this is how nitrogen deficiency will look like, this yellowing of leaf, and this is potassium deficiency where there are spots on the leaf and near the veins there is this characteristic yellowing. And this is magnesium deficiency where you can see clearly that near the entire leaf lamina, almost 3/4 of the leaf lamina is completely becoming yellow in color. Now, deficiency, if they tend to appear in young tissues, if it's a immobile elements. Now, mobility of elements, we have also dealt much detail in transport of the elements of the transport in plants chapter also. There you can please go back and refer. So, the deficiency symptoms that tend to appear in the young tissues, they are relatively immobile and are not transported out of the mature organs. So, immobile elements, the deficiency is seen in young plants, whereas in mobile elements, it is seen in older leaves. Example, sulfur and calcium, both are the part of structural elements of the cell.